In this section, we're going to take a look at solving linear inequalities. The good news is solving linear inequalities really isn't any different from solving linear equations, with the exception of one rule. And the one rule is when you divide by a negative, or multiply, when you multiply or divide by a negative number, like my E there, flip the inequality. Alright, and I've had many times where students have asked me, why do you do that? Well, it's pretty easy to show. I think you would agree that negative 3 is less than 2. But look at what happens when I multiply both sides of this by a negative number. Let's say I take this inequality and I multiply both sides by negative 4. On the left, I have negative 4 times negative 3, that's 12. On the right, I've got 2 times negative 4, that's negative 8. Clearly, the inequality now has to go the other way. 12 is greater than 8. And it doesn't really matter if I start with one positive and one negative. Let's say I started with 3 less than 7, and I decided to multiply both sides by negative 2 maybe. I would have negative 6 over here, and I would have negative 14 over there. The inequality has to go the other way. It's just the way it works. Okay, so we're going to solve linear inequalities. Linear inequalities are very much like linear equations. The only difference is they have a less than symbol or a greater than symbol or a less than or equal to. So remember linear. Linear means that we don't have powers. Linear inequality might look something like 2x plus 7 less than 5x minus 9. We solve it the same way we solve a linear equation. We get all the x's on one side. Doesn't matter if you put the x's on the left or on the right, but for inequalities, I really pretty much recommend you put the x's on the left, and I'll talk about why I think you should do that here in a few minutes. So I put the x's on the left, negative 3x plus 7 less than negative 9. Subtract 7 on both sides. Negative 3x less than negative 16. Here comes the important one, divide by negative 3. I'm dividing both sides by a negative number. When I divide by a negative number, I have to flip my inequality. So I end up with x greater than 16/3. Okay, so there's the type of linear inequality you're going to be expected to solve. Pretty simple, I hope. The next thing you're going to see something called a compound inequality. Compound inequality just means there's more than one, so you might have something like negative 5 less than or equal to 2x plus 3 less than 9. And you want to solve. By solving, what we mean here is we want the x all by itself in the middle and numbers out on the ends there. So really nothing new here. We need to get rid of the plus 3, so we do a minus 3. The difference is you don't need to do it on both sides. You need to do it in 3 places. Not really a big deal though. Negative 8 less than or equal to 2x less than 6. And then we divide by 2 everywhere. But we're dividing by a positive number, so we don't need to flip any inequalities. We're left with negative 4 less than or equal to x less than 3. Okay, so there's the basics of solving inequalities. Now, what they ask you to do in your book quite often is they ask you to solve and then write the answer in interval notation or graph your answer. So I want to talk about those for a few minutes. There's 3 different ways we write our answers. There's inequality, there's graph, and there's interval. And you should be equally comfortable with all 3 notations. Inequalities, I don't think these cause you any problems. X less than 3. I think you're very familiar with that. here's why I think you should always put the x on the left. When you go to graph x less than 3, you draw your number line, there's 3. We have the less than symbol, so we put a circle around it because there's no equal to. If we had less than or equal to, we would draw the circle and then we would fill it in as a dot. And I'll do an example of that in a minute. And then you shade to the left. And the arrow of the inequality symbol always tells you which way to shade as long as you have the x on the left. And what I will find is when students put the x on the right, quite often they'll shade the wrong direction. So we shade to the left. So there's our answer in graphing notation. Now, interval notation. Interval notation uses parentheses and square brackets. And the way it works is you look at your answer and you put the smallest number on the left. The smallest number, this one goes to the left forever. So our smallest thing would be negative infinity. And then we put the biggest thing on the right. This one stops at 3. A positive infinity or a negative infinity always gets a round bracket. The 3 in this case also gets a round bracket, a parenthesis, because there's just a less than back here. If there were a less than or equal to, then we would use a square bracket. So let's do an example of that and see how the difference is in the number line also. Alright, so let me just, here's another new example. Let's say I gave you x greater than or equal to 2. Alright, number line, pretty simple. There's 2. This time I have the equal to. Since I have the equal to, I put a solid dot right there. And this time it's a greater than. I shade to the right. So there would be my graph answer. Inequality answer, I put the smallest number on the left. The smallest number this time is a 2. I put the biggest number on the right. That's an infinity. Infinity always gets a round bracket. Always, always, always. No discussion on that. The 2 this time, however, gets a square bracket. The 2 gets a square bracket because it has the equal to back here and because it's got the dot back there. So I hope you see the difference. If you have just a less than sign or just a greater than sign on your graph, you're going to get an open circle. On your interval, you're going to get a round bracket. When you have the equal to sign, as we do in the second example, you're going to get a solid dot and you're going to get a square bracket. Alright, how about one of those compound inequalities that we had? I don't remember exactly what the answer was that we had on that problem we did a few minutes ago, but it might be something like negative 5 less than x less than or equal to 4. Here's one of those compound inequalities. Number line, I draw my number line. There's negative 5. There's 4. Negative 5 gets a circle because there's no equal to on that end. But 4 gets a dot because there is an equal to there. And we would shade in the middle. Similarly, in my interval notation, I would put my smallest number on the left, that's negative 5. Biggest number on the right, that's a 4. The negative 5 gets a round bracket because there's no equal to there. 4 gets a square bracket because there is an equal to there. Alright, the last thing I see in this section is finding domain. And domain problems here deal with square roots. So I might ask you, f of x is the square root of 2 minus x. What's the domain? Well, when you have a square root, you cannot have negative values underneath the square root. So whatever underneath the square root has to be greater than or equal to 0. So all you're going to do here is 2 minus x greater than or equal to 0. And you're going to solve that inequality. To solve it, I would write minus x greater than or equal to minus 2. And then I would divide both sides by the negative 1, remembering to flip my inequality sign because I divided by a negative. X is less than or equal to 2. So those problems shouldn't be bad. Whenever you have a square root, whatever's underneath the square root has to be positive. And the other thing we talked about with domain, whenever you have a fraction, you cannot have 0 on bottom. So when you see domain problems, at this point, those are the two things you need to worry about. No negatives under square roots, no zeros on bottom.